Hi everyone, we're starting on lesson 9.3 today, combining two functions, products. So in the previous lecture, we talked about the violin and how each string creates a sine wave. Now as the sound weakens, the sine wave becomes squashed, which is known as damping. This can be expressed as the product of a sine function and another function. So we multiply two functions together. You guys know the three methods: numeric, algebraic, graphical. I'll briefly go through them. Numeric is evaluate first, then combine it together. Algebraic is combine the equations first, then evaluate. And graphical, well, the graph of h of x can be found by multiplying the output of f of x and g of x as a specific input. Let's take a look at example 3 from your learning resources. Determine the shape of y equals to f times g of x, given the function f of x equals to x squared plus x minus 6 and gx equals to x. This may sound complicated at first, but we'll go through this step by step. So first we have to know what f of x function looks like. We can rewrite this f of x function as f of x equals to x times in bracket x plus 1 bracket close minus 6. So it's this curve that has a vertical translation of 6 units down and a horizontal translation of 1 unit left. So it looks something like this. That's this curve. G of x equals to x, everybody knows what that looks like. It's just a straight line going through both the axes at once. So we have to combine these two functions. How do we do that? Well, we know that anything times 0 equals to 0. So at the point where we have f of x equals to 0, that means doesn't matter what g of x is, f times g of x will be equal to 0. So one point is at x equal to 0, f of x equals to negative 6. But g of x equals to 0. So it doesn't matter what f of x is, f times g of x will be equal to 0 because negative 6 times 0 equals to 0. Similar calculations are made from negative 4 to 4 as shown below in the table that's going to be in the next slide. And note how both function f and g are second and first degree polynomials respectively. For the product, will yield a third degree polynomial function, which is a cubic function. Notice the zeros in here. We have when f of x equal to 0 and negative 3, g of x equals to negative 3, so f times g of x will be equal to 0 because 0 times negative 3 equals 0. Here we have another 0 when g of x equal to 0, f of x equals to negative 6. This one we already talked about in the previous slide. So f times g of x equals to 0. And another one occurs here where f of x equal to 0 and g of x equals to 2 at x equals to 2. So we do this for many points that we need, and we multiply these two functions, and we'll get f times g of x. So that's the end of this lecture. Thank you guys for watching. Remember to do your activity video as well as upload them for your teacher to mark. And I'll see